This video is going to focus on discrete random variables. So a random variable is a value that describes the outcomes of a chance process. In this video, we will only be focusing on discrete random variables, which describe all probabilities in terms of separate outcomes. There are two criteria for discrete random variables. The probabilities must be between 0 and 1, and all the probabilities must add up to 1. So this is an example of a probability distribution chart. All possible values and the probabilities of a discrete random variable are defined. The p-values are the probabilities that describe the corresponding x-values of a discrete random variable. To find the probability of a certain event, you add up all the probabilities that correspond with the x-values that make up that event. The mean of a discrete random variable is also the expected value. To find this value, you multiply possible values with the probabilities and then add them all up. So now we're going to focus on standard deviation and variance. Standard deviation describes the average deviation of the variable x from the expected value. To find the variance of x, you have to add the individual variances. To do that, you take the difference between the value of x and the mean, you square that difference, and then multiply that by the corresponding probability. Once you have the variance of x, you can find the standard deviation of x by taking the square root.
On the AP test, you might be asked to find a probability such as the one in this problem, where x is greater than or equal to 1. To solve this problem, you could add up the probabilities of x equaling 1, 2, and 3, or you could make your life easier and take the probability that x equals 0 and subtract it from 1.
Alright, so part B is asking us to find the expected value of the number of ATMs that are working when the mall opens. There are two ways we can do this. One is by taking the possible outcomes and multiplying them by their respective probabilities, and then adding each of these values up. And then another way we can do this is by using our TI-84 and creating two lists by pressing Stat and then Edit. And in list 1, we put the possible outcomes, and in list 2, we put the corresponding probabilities. Then we press Stat again, and instead of under Edit this time, we go under Calc and press 1var stats, and then List, this is our list of outcomes. We select list 1 by pressing second Stat, which takes us to the lists, and then select L1. And for the frequency list, we select L2, which is list 2, and then press Calculate, and the number all the way at the top is our expected value. And one of our stats actually gives us a lot more than just the expected value. It gives you the variance, standard deviation, and even the 5-number summary if you scroll down.
In this part, we want to find the probability that all 3 ATMs are working when the mall opens, given that at least one ATM is already working. Part C is testing us on conditional probabilities. While the question is mostly testing how well you can manipulate probabilities, it's still important that you're able to get the probabilities from the probability distribution. Part D is asking us about expected values again, but this time it's asking us how that expected value would change if we removed one of the categories. We know from Part B that the expected value is 1.73 machines working at opening. Remember, it's okay to have a decimal for an expected value. The problem is telling us we can eliminate the possibility of 0 ATMs working when the mall opens. Since the other probabilities have to add up to 1, it means that the probabilities respectively of 1, 2, or 3 ATMs working when the mall opens would each increase. This would raise the expected value.